Okay, good morning to everyone. So in the last class, we have seen the introduction, that is derivation of this Varignon's theorem. Okay, so what this Varignon's theorem says: the algebraic sum of all the moments of all the coplanar forces algebraic sum of the moments of all the coplanar forces about any point or moment center is equal to the moment of the resultant about the same point of or moment of center. Okay, so whenever you consider any system of coplanar forces, the moment of all those forces about the moment center is equal to the moment of the resultant of those forces about the same point. Okay, in this figure, the F1 and F2 are the two forces which are coplanar, and the resultant of these two forces is this R. Okay, resultant force. Then the moment center is O. The moment of these forces F1 and F2 about the point O. The algebraic sum of the moments of forces F1 into D1 is the moment of the force 1. F2 into D2 is the moment of the second force, is equal to the resultant force, moment of the resultant force. So the resultant force is, wait a minute. So this is a resultant force R. Okay, so this is resultant force R. Okay, R into D. So here it is resultant R. That's why it is also equal to R into D. So F1 into D1 is the moment of first force, F2 into D2 is the moment of second force, and R is the resultant of these two forces. Hence, according to the Varignon's theorem, the algebraic sum of all these moments of all these forces is equal to the moment of the resultant force. Okay. Okay. We will see for the next what we have seen. And also we have determined that is the X-intercept and Y-intercept. Okay, so this one we have seen X-intercept and Y-intercept, correct? So what is X-intercept? That is X equal to a summation of M divided by Fy. The Fy is nothing but algebraic sum of all the forces along the y direction, and Y is equal to summation of sigma M divided by Fx. That is Fx is equal to summation of all the forces along x direction. So in the problem, you have to determine the resultant force and its direction. Also, you have to determine the position. Okay, that is D are X and Y. Okay, so we will see one problem so that you will come to know. Okay, just I will write that problem here. Find the magnitude and magnitude, comma direction, and position and position and position of resultant force with respect to point A. With respect to point A. Okay, this is the problem that is given in the given. Okay, So in the figure it is given. So I have to draw the figure also. So just see the figure. There is one triangle. This is a problem which is given in the so in there are namings. Name the first point is it is A. This is A. This point is B. This point is C, and this point I will take it is D. Okay. It is I will take it is D. This point is D. And the sides is given. Triangle side is it is 200 mm. So here it is passing exactly middle of the sides, that is equal to 50 mm, and this is also 50 mm. Okay, so here it is a triangle is given and the force is also given. So this is 30 kilonewton force, 30 kilonewton. This is 60 kilonewton, 60 kilonewton, and this force is given 50 kilonewton, 50 kilonewton, and there is one more force vertically downward, it is 80 kilonewton. Okay, 80 kilonewton is given. Okay, so I need to find out the resultant of these forces about the point A is given. Okay, so what is first step? First step is yes, it is. So first, what I have to do find out. So to find. Okay, what all should we find out? First, I need to find out the resultant force, that is magnitude of the resultant force. Next, I need to find out the direction, that is alpha. You can take that is direction. Alpha is equal to how much? Next, position. Position means you have to determine a D, and you have to determine a X, and you have to determine a Y. Okay, these all you have to find out. Okay, so next, so what is the first? So starting from the first point, so first I will write. First step is what? We have to find out the resolving all the forces horizontally. Okay, so what is a horizontal force? That is sigma fx. So this sigma fx is equal to, so first I will take this force is F1 force. Okay, so this is F1, and I will take this is F2, and this is F3. It is my convenient, I am taking F3, and this one is F4. And this is F4. Okay, so next, what is to be done? So sigma fx, that is what is sigma fx? That is sum of all the forces along the horizontal direction. So in F1 force, it is purely vertical. So is it producing any horizontal forces? No, because the angle made by the force with the horizontal is 90 degree. The component is F cos theta. Hence cos 90 is equal to 0. Hence it is not making any force. So if you want to write, you can write that is plus 80 cos 90. So that is it is making 0. Then second force, coming to the second force, this F2 is purely horizontal direction. So that I will write it is purely 30. Okay, because it is horizontal. Theta is 0, hence cos 0 is equal to 1. So F cos 0 is 1. Next, so this F3 force is, it is in first quadrant. Okay, so it is moving in horizontal direction, that is x direction. So its x component is 60 cos as this is equilateral triangle, the angle is 60 degree. Okay, so this all the angles are 60 degree, but this is exactly half of the 60, that is equal to 30 degree. Okay, so this F3 force is making angle 30 degree with respect to horizontal. Then is its x component is equal to F cos theta. So that is plus F is equal to 60 cos theta. Theta is equal to 30 degree. Okay, next third force over here. So next fourth force, that is F4 force is making an angle of 60 degree with respect to horizontal. So is it moving in the right side direction or left side direction? It is in left hand side direction. Hence the force is negative. That is 50 cos theta. Theta is how much? That is 60 degree. Okay, that 60 degree. So calculate its value. So this, hence sigma fx. Sigma fx is equal to you will get 56 point. Sigma fx is equal to sigma fx. Sigma fx is equal to 56.96. 56.96. Okay, that is in kilonewton. All the forces are in kilonewton, and hence the answer is it is in positive. It is in positive, so we are taking it is right hand side direction. Okay, sigma fx. So similarly, you can find out the sigma fy. So sigma fy is equal to, so I will take sigma fy. So this is sigma fy. So second step, that is resolving all the forces along vertically. Okay, so along the vertical forces, so that is sigma fy. Sigma fy is equal to, what is sigma fy is equal to? So f1 force, it is purely a vertical direction, hence it is downward direction, minus it is 80. Next, this is 30 kilonewton, it is purely horizontal, it will not produce any vertical movement force. Okay, hence I will not take this one. So again, this is 60 kilonewton. This 60 kilonewton is making an angle 30 degree with respect to horizontal. Then it is moving upward direction. So it is positive 60. Theta is 30 degree. That is sine 30. Next, this is 50 degree. Okay, 50 kilonewton. This is also moving upward direction, making angle 60. So plus 50 kilonewton sine. Okay. So it is 50 kilonewton is a force into sine 60 degree. Sine 60 degree. So that you will get the value of sigma fy. The sigma fy you are getting, that is minus 6.698. 6.698 kilonewton. Okay, that is sigma fy. Okay, everyone, is it, are you finding? So here you have determined the value of sigma fx. Here you have determined the value of sigma fy. Next, for next third step is you have to find out the value of, resultant force. So third step, resultant force. Resultant force. Resultant force. Okay. So what is the resultant force? First, that is you have to find out the R is equal to under root of sigma fx whole square plus sigma fy the whole square. Okay, so this is under root. You have to take under root. Okay, so substitute the values. That is sigma fx is you are going to take magnitude only. That is 56.96 square plus plus that is 6.698 whole square. Okay, so this is one. Next, you can find the value of R. So all of you find out this value of R. So R you are getting that is 57.35 kilonewton. So 57.35 kilonewton. Okay, this is the value of R. This is the value of R. Okay. So next you have to find out the value of magnitude. So magnitude is over. Next is you have to find out the direction. So how to find out the direction? So direction is equal to alpha is equal to tan inverse of sigma fy upon sigma fx. So that is equal to sigma fy tan inverse of sigma fy is how much? Take the only magnitude. Fy is 6.698. 6.698 divided by what is sigma fx? 56.96. 56.96. Okay, so that you will get the value of alpha is equal to that is 6.7 degree. 6.7 degrees. So finally, I have to represent this in a tabular graphical representation. So how to represent that is you can take this one. Okay, so see sigma fx is moving right hand side direction. Point sigma fy is moving downward direction. Okay, so this is downward direction. So it is sigma fx is positive direction. This is sigma fx, and sigma fy is it is in downward direction. So downward direction is this is downward direction. Okay. Next, your resultant force is making an angle. How much it is? 6.7 degrees. So this is the resultant force, which is making an angle 6.7 degrees. Okay. So this is the value of alpha. This is the value of resultant force. Okay, this is sigma fx. Okay, and this is downward is sigma fy. Okay, this is sigma fy. So this is how you have to represent. So it is in fourth quadrant. Sigma fx is positive, sigma fy is negative, and it is in fourth quadrant. Okay, next is you have to find out the what you have found out resultant. You found direction. You have to find out D. In order to find out the D, I have to find out moment about the point A. So how to find out the moment about A? That is equal to so step number 5. Moment about a point A. Okay, so that is summation of moment about A is equal to. So summation of moment about A is equal to. That is first you have to fix this point. Fix up this A point and apply all the forces F1. So consider there is no any other force. Only F1 is there. So F1 is rotating clockwise direction. Correct. This F1 is rotating clockwise direction. In clockwise direction. So it is plus. How much is the distance? The distance is 50 mm, 50. So the force is 80 kilonewton. So 80 kilonewton is the force. That is, it is positive. positive 80 kilonewton into the distance is 50. Okay, next second force. Coming to the second force. Second force is F2. This F2 is passing through the given point A. It will not produce any moment. Then coming to the F3. F3 force is passing through the point given point A. That is also not producing any moment. Okay. Then F3 force. F4 force. This F4 force is inclined at an angle of 60 degree. One is horizontal component and one is vertical component. This horizontal component is F cos theta is passing through the given point A. Hence, it will not produce any moment. Then the one more is vertical component. This vertical force is F sin theta is rotating in anti-clockwise direction. Hence, F is 50 sin 60. So that is minus 50 sin 60. That is force into perpendicular distance is 100. So that is equal to, so total final answer you have to find out. So that is 80 into 50. No, 80 into yes 50 or 100 it is. No, it is wrong. So if it is a 200, if it is 200, so this is 100 and 100 it is. Not as 50 and 50. Okay. So this is 100 and 100. Okay, it is 100 mm. And it is also 100 mm. Okay, so if it is 100 and 100, so this is equal to, it's not 50, it is 100. It is 100 and it is 200. So it is 80 into 100 minus 50 into sin 60, that is 200. So you will get the answer, it is minus 660.25 kilonewton. 25 kilonewton millimeter. Okay, the forces are in kilonewton and the distance is in mm. So answer is kilonewton millimeter. This is moment about a point A. Next, the sixth one. So sixth one. What are you to find? Position. That is you have to find out the D value. D is equal to sigma m about a point A divided by, that is your R value. So sigma m you are getting 660.25 divided by, what is the value of R? So value of R you got 57.35. So it is 57.35. Okay. So we will get the value of D. So the D is 11.51. 11.51. Okay. 11.51. 51 mm. Okay. So this is how you have to find out the value of M. Okay. Next, what you have to find out? You have to find out the value of intercepts. Value of intercepts. So first, you have to go for intercept. That is okay. Intercepts. So first intercept is x. X is equal to summation of m about a given point A divided by sigma fy. So this sigma fy, m about A is how much? It is 660.25 divided by what is sigma about m summation of fy? That is summation of fy is equal to 6.69. Okay. So it is 6.69. 6.69. 6.69. Okay, so calculate the value of x. Calculate the value of x. That you will get 98.57 mm. Okay, then again y-intercept. Y-intercept is equal to summation of m about a point divided by summation of fx. So what is the value of summation of m about a? That is 660.25 divided by divided by 6.69. 660.25 divided by sigma summation of sigma fx. Sigma fx is 56.96. That is 56.96. 56.96. So that you will get the value of y. Y is equal to 11.59. 11.59. So these are the answers. Okay, these are the answers of X, Y, and D, and also you have to find out. Okay, these are the X, sigma fx, sigma fy, resultant, and alpha is 6.7 degree. Okay, finally you can write all these things. So find the result, you have to find, you can write all these things. Okay. Yes, okay. So we'll take the other example in the next class. I will give one problem for the homework. You just try this one. Okay. Calculate magnitude. Calculate magnitude, direction, and position of resultant force as shown in figure. As shown in figure. Okay. This is the given statement. Okay. So we just find out magnitude of all these points. First, I'll take this problem. Let it be. Gives you one B. Or that there are forces, system of forces. Okay. These are the system of forces. So the given points are, so this is A point. Okay. Then the distance is 1.5 meter. 1.5 meter. And this is also 1.5 meter. And this is 3.0 meter. And this is 2.0 meter. Okay. So the forces are 20 kilonewton. This is 20 kilonewton. This is 30 kilonewton. 30 kilonewton. And this is 20 kilonewton. 20 kilonewton. And it is making an angle of 60 degree. This is making an angle of 60 degree. Okay. Just I will take it easy. So from here to here it is 1.5 meter. From here to here it is 1.5 meter. From here to here it is 3 meter. And again it is remaining 2 meter. Okay, all are in meters. Okay, this is 1 point. So second problem. Let's go in the PPT, it is there. Okay, all of you see the PPT. You have to find out this one. In the PPT, there is a process. Okay, you have to find out the moment about A. Take it in this point. So you have to find out the moment about this point A. Okay, about the point A. So this is the point. Okay, about this you have to find out a moment. So this is one problem, that is one problem. You have to solve these two problems and we'll continue the next class. Okay, thank you. We'll stop now here. We'll continue the next class. Thank you.